social sciences, we said we will do our study at 95% confidence level. Therefore, our error margin will be 5%. That's a very huge margin that I think the natural sciences guys don't enjoy. If you're an engineer or you're a doctor, you're doing a research on vaccine or maybe a new product for the airplane, you realize you don't have a luxury of having an error of up to 5%. You might end up killing people. But because for us, we are working on, under the humanity and social sciences, we say we have up to a threshold of 5%. So with this 5%, you can convert it into value. And if you convert 5% to a value, then you'll get a value of 0.05. Therefore, at 95% confidence level, your alpha value will be 0.05. If you're doing a study at 99% confidence level, then your alpha value will be 0.01. Step number 4, we said, is the decision-making step. And for you to make a decision on whether to stick by the status quo, which is the null hypothesis, or reject it and opt for alternative, then you need to do a comparison between a probability value and the alpha value. So where are you going to get the p-value? You get the p-value by doing the analysis. So you're going to perform chi-square, and then out of the chi-square results, we'll be able to get this p-value. Now this p-value is what now we're going to compare with our alpha value. And I've said the rule of thumb is, in an event that your probability value is less than the alpha value, then that is when you reject the null hypothesis. Step number 5, of course, whether you reject or you fail to reject, you'll now have to talk about your conclusion. What does your study conclude? So let's see what we have in this case. So to perform chi-square test of association, I'll go to analyze, descriptive statistics, analyze, descriptive statistics, then I select cross tabs. That means I'm doing some sort of cross tabulation. And with cross tabulation, it doesn't matter which one goes to the rows and which one goes to the column. Okay, so we call it a contingency table. So I'll transfer gender to the row part or the row section, and then employment category I'll transfer to the column. Now let's look at the exact, because like I said, I'm not so sure of my audience, but I believe you guys are coming from different universities and different departments. But just an overview for someone who's so deep into statistics, for someone maybe who's doing economic and statistics or pure statistics, this interface might make sense to you. But for someone maybe who's doing psychology or sociology, don't worry about what I'm about to talk about here. So at the moment we're doing what we call asymptotic only. That is the assumption for our test. But we have something called Monte Carlo simulation. And this is where if your distribution follows this Monte Carlo simulation, which basically means, which is a concept that most guys from Chiroma, or those that who are doing statistics, they do a lot of simulation. And with simulation, once you select it, you have now the ability to choose your confidence level and also the sample. But because we are working under the assumption that our data is normal, because actually most of the tests that I've been doing with you guys are what we refer as parametric tests, which basically means you're assuming that your data is normal, so you don't have to be doing the pre and post estimation test. But in an event that you're really working with a real data set or some organization, sometimes they set standard. I think even in academic level, you might be required to do those diagnostic tests before actually you do any analysis. So for now, I'll just stick by asymptotic only, because there's also option of exact, but I don't want to start teaching against statistics here, because I believe most of these things, maybe there's a forum for that, which I believe is now your undergraduate. So if your lecturers have been doing their job, then you should be comfortable with what I'm talking about. So I'll click continue. I have the option of statistics. And with statistics, that is where now I'll select chi-square, because the test statistic that I'm doing is chi-square test of association. There's a lot of tests that you're seeing here. Things like Kendall style A, we have Kendall style B, we have lambda, we have the phi grammars. All these things, I think, are the things you might learn with time. So if they're relevant with your course, then take time to understand them. But for now, I'll be biased with chi-square test because that's the scope of my work today. So I'll select chi-square test, click continue, and then I'll paste. I'll execute my syntax. Okay, I think let me apologize for that before I disappeared, but I'm not so sure at what point I was off. But let me just start by executing this command. And I said once you execute the results, you get your results here. The first table is on case summary, so there's no big deal about that. It's all about the distribution, how many participants are there. You can see 474. I think there's nothing much to explain here. On the second one, which is the gender and also employment category cross tabulation table, this is the same table that we were able to obtain using the pivot table yesterday. And as you can see, it tells about the 74 male managers and 10 female managers. I think that's where we obtain the narrative of the first objective. I will say like, okay, let's investigate if there's a relationship between gender and employment. The last table, which is the most important one, now this is the chi-square test. And in this table, we're just looking for the probability value or the p-value. So if you follow the Pearson chi-square all the way to the end, where you're seeing asymptotic significant two-sided, you can see a value of 0.000. What does this mean? This figure is less than 0.05. Remember rule of thumb in step number 4, when the p-value is less than alpha value, that is when you reject the null hypothesis. So we're going to reject the null hypothesis, which said there is no relationship between gender and employment category. And now we will go for the alternative, which says there is a relationship between someone's gender and their employment. So what does that mean in English? So in your conclusion or discussion, you will say, among the factors that contribute to someone assuming a certain employment position, gender is one of them. Among the factors that contribute to this employee assuming a certain employment category, gender will be among the significant factors. So of course that word significant I will be introducing more in the next test, but every time you find that your probability value is less than alpha value, then you realize that your findings are significant. That's why you are rejecting the null hypothesis and you're going for the alternative. So you'll not go for an alternative, let's say dogma or paradigm, unless they are statistically significant. So in this case, you can say there is a significant relationship between someone's employment and their gender. In terms of recommendation, because I don't advocate for just researchers who identify problems and arrive on conclusion, our job as researchers is to also provide solution. So what do you recommend in such a case? One, you can recommend the affirmative action. I think that's one way of going about this. And what it means by affirmative action, this is where you can say, oh, let me create a certain position that can only be meant for women. And a good example is in our political system, whereby we have the women rep positions. So George today cannot decide to be a woman representative for Nairobi County. Doesn't work like that. So because that's an affirmative position. Apart from affirmative action, I think what can be other recommendation? So maybe you lower the standards, things to do like, I don't know if it's appropriate for the business, but I think it happened in our education system. So in our education system, I think some years back, there were different entry point to the university, whereby I think certain gender had a lower cutoff point to go to public university compared to another gender. And I think such thing was brought about because of the disparity in enrollment in universities, whereby they decided to make some adjustments. So I think I don't want to talk more about recommendations, but a good researcher should also provide solution, so that on justification, or sometimes we talk about novelty of your work, people tend to read this research because of what you recommend, not just because you have identified a problem. Let's talk about the second test, and this time we want to check if there's a relationship between employment category. Sorry, we want to know if there's a relation between salary and education level. We want to know if there is a relationship between someone's education level and salary. So both of the variables are continuous, and with Pearson correlation, which I said is the test you do when you're comparing two or more continuous variables, I want us to pay attention to 4 to 3 different things. As much as we are guided by the 5 steps of conducting any inferential analysis, in correlation analysis or Pearson correlation, there are 3 things that must come out very clear in your interpretation. Number 1, you must talk about the direction of that relationship. And when I say direction, is it a positive relationship or a negative? That's on direction. 2, you must talk about the strength. And when you talk about strength of that relationship, you can say, is it a strong relationship or a weak relationship? The last one, which is the third part, you must talk about significance. So this relationship, which is a strong positive or weak positive, is it significant at whatever confidence level you're doing or not? Let's understand further what it means by direction. And there are 2 types of direction that a relationship can take. And how you note this is based on the operator or the sign that you'll get out of the correlation coefficient. So there's some value that you're going to get out of our results. That's why we call it a coefficient. So a coefficient is just a number. And we will pay attention to the sign in this coefficient. So if you see a negative sign, then it means that is a negative relationship. If you don't see any sign at all, then of course the assumption will be that that is a positive relation. So what does it mean when you say a relationship is positive? What it means there is, as one variable increases, the other variable also increases. So both of those variables are headed in the same direction. And vice versa is also true. As one variable decreases, another one also decreases. A good example is on the law of demand and supply, whereby the relationship between price and demand of a commodity is negative. I don't know if I was talking about negative or positive, but I think let me just use those examples. Or for positive, now we can say the relation between the price of a commodity and supply of a commodity is positive. What does that mean? If you increase the price of a commodity, chances are manufacturers will supply more. So as prices goes up, supply goes up. That's a positive relationship. When we talk about negative relationship, it means it's inverse. And with inverse, it means they are headed in opposite direction. As one increases, the other one decreases. A good example is price and demand. When price of a commodity goes up, people tend to demand less, or actually even look for alternative or others. So I think those are the two examples of the sign. So negative, we say positive heading in the same direction, negative opposite direction. On strength, or how do you identify if something is strong or weak? So we say in terms of strength, we'll talk about a strong relationship or a weak relationship. And just like probability, the highest chance of something to happen is always up to 1 or 100%. So applies also for correlation. So for you to have a perfect correlation, or for instance, if you correlate salary against salary, you're going to get a perfect result, because that is you correlating something against itself. And when you say a perfect result, then it means you'll get a coefficient of 1. So the midpoint of this 1, because let's say 50%, if you obtain a coefficient that is less than 50% or less than 0.5, then you'll say that is a weak relationship. If you obtain a coefficient that is above 0.5, which is a half of 1, or you can say also 50%, then you can say that is a strong relationship. Now, for those who have done hypothesis testing in campus, you realize that if you say 1 is a perfect relationship, then 0 means there is no relationship between those two variables at all. Therefore, in an event that you're going to get a coefficient that is not the same as 0, then that means your findings are significant, because you're getting something that is not 0. And I said 0 in this case means there's no relationship. 1 means there is a perfect relationship. So even by the fact that you're running correlation analysis, it means you're actually doing what you call hypothesis testing. If I had a board, maybe I would have now maybe go and write those mathematical concepts of what we're doing. But for now, let's just use the wording. So when you say there is no relationship, that will be your null hypothesis. So the null hypothesis will be there is no relationship between someone's education level and their salary. The alternative hypothesis will be there is a relationship between someone's education and salary. Of course, we need to reject the null hypothesis. And I said, if we get a coefficient of 0, then automatically we'll be sticking by the status quo, which is there is no relationship. But if you're going to get something other than 0, then that is when we will go ahead and interpret in terms of direction and also in terms of strength. Let's run the correlation analysis so that we see how we'll go about this one. And to perform correlation, just go to Analyze, Correlate, then select Bivariate, Analyze, Correlate, Bivariate. Bivariate basically means you are handling 2 or more variables. I'll select current salary and also education level. If you check on the correlation coefficient, so at the moment we are doing Pearson correlation. Of course, we're just following the assumption of this guy called Pearson. So even for chi-square, we did Pearson chi-square, just the same idea from this guy called Pearson. But I've mentioned of non-parametric tests. And in an event that we were doing, or if you're doing correlation for data set that is not normal, then that is when you either go for Kendall style A, we also have Kendall style B, or Spearman rank correlation. I think rank correlation, most of us we did in statistics 2 or statistics 1 in campus. But for now, let me stick by Pearson correlation. Now, let me give you as a challenge. So go and find out what's the difference between two-tailed test and one-tailed test. And hopefully in our tomorrow's class, we will have answers between the two. If you guys will not provide for me the answer, then I should be the one providing the answer to you guys. So it would be good if you guys go and do your own background check on the difference between two-tail and one-tail. Though in class today, I'm going to pick on two-tail because that's what we're doing at the moment. So it's just you to find out why I'm opting for two-tail and not one-tail. If I paste, I can go to my syntax, and if I execute that, and I have a correlation coefficient, sorry, a correlation matrix. And I know even in the assignment that you guys will be doing today, when they talk about correlation matrix, don't think it's a certain analysis complex thing that you need to do. No. We're just asking for this table because it's a table that on the rows you have the variable and also the same variable up also on the column. That's why we call it a matrix. So it's a correlation matrix. That's a row by column table. Now let's focus more with the interpretation. And remember we said a perfect correlation is when you correlate something against itself. So salary against salary, if you follow the Pearson correlation item, so just follow Pearson correlation for current salary against current salary, you're getting a value of 1. Same applies to education against education. So it doesn't matter how you're following, whether you are following from the column side or the row side. We're still getting the same result. So if you check between current salary and education level, you're getting a figure of 0.661. That's like 66%. So one, in terms of direction, I can say there is a positive relationship between someone's education and their salary. What does it mean when you say positive? It means as one variable increases, the other variable also increases. But correlation doesn't tell cause and effect. So you cannot say education is the one solely making current salary to increase. No, but we just say as someone education level was increasing, their salary was also increasing. That's a positive relationship. In terms of strength, we said the cut point is 50%. So 66%, what we're seeing here, is about 50%. So we can say this relationship, which is positive, is also strong. So there's a strong positive relationship between current salary and education level. The last part is on significance. And of course, I said you can tell the significance by 2 ways. But the fact that you're getting a coefficient that is not the same as 0, you will figure out on whether you are rejecting the null hypothesis or not. So of course, because you're getting 0.66, it means you're finding that significant. Because we're not saying the coefficient is the same as 0. Instead, we're going for the alternative, which says the coefficient is something not the same as 0. That means it's 0.66. Apart from using the coefficient as a way of telling the significance, you can also use this significance at two-tail. That is the p-value. And I've introduced the part of using coefficient to tell significance because in our next software, which is theta, when we will be doing correlation, we will not be able to get both the coefficient and the p-value. Theta results output only provide the coefficient. And that's why I think most economists define theta as their software because it summarizes work for them. Of course, without even the provision of p-value, an economist can interpret that 0.66 as a significant figure. So in as far as conclusions is concerned with these results, we can say at 95% confidence level, there is a strong positive relationship between current salary and education level. Let me repeat that. At 95% confidence level, there is a strong positive relationship which is significant at 95% confidence level. Or you can still play around with this word. You can say there is a strong positive relationship between current salary and education level, and this relationship is significant at 95% confidence level. No matter how you organize your wording, I've just said make sure you capture the concept of direction, capture the concept of strength, and also capture the aspect of significance. Unless there's a question, I will save the remaining part of our analysis, which is independent sample t-test, which is a situation whereby you have one variable in continuous form and another one in categorical. So we will do that tomorrow. Also, tomorrow I will be finishing up with regression analysis, whereby we will see on the last objective, whereby we want to know now if we have said that there is a strong positive relationship between someone's salary and education level, can we be specific and tell to what extent does education affect salary? So we need to get a figure, we need to do some estimation. And that's what we're going to do tomorrow so that we can tell if education adjusts by 1 unit, somebody's salary will respond by a certain margin. And with that said, I've shared some few notes on linear regression. And basically my class tomorrow will be a summary of these notes. So I don't want you to feel like out of place when I'll be mentioning some terminologies, but at least between now and tomorrow, make sure you go through this document. And especially those who are not from, let's say, economics or a more quantitative background. So pass through this document, and more so, I want you to be comfortable with the following. So one, there are several tests that we'll be doing in regression. So I want you to be comfortable with what coefficient of determination is. And you don't have to depend on my notes, just in case there's a place you can find information on coefficient of determination. Please remind yourself on the same, and coefficient of determination is also referred as R squared. So you need to know what that is. I also want you to look at the aspect of goodness of fit. And this is where we'll be talking about F test. Sometimes you also refer to it as ANOVA. So your work is simple. Just revisit on the theory. Don't go into some deep stuff doing all those calculations. If those formulas were not making sense to you before, don't go and crucify yourself with the disguise that I've said you go back to your notes. No, I just want you to familiarize with it so that we can concentrate more on the practical. The software is already here. It will do all those maths for us. So our goal is just to remember the assumption and also the interpretation. Apart from F test, I also want you to read on T test. And this T test is, so of course we have two types of T test. Let me just mention it. So even tomorrow when we will be talking about independent sample T test, or when we are comparing means, we'll look at, I think we have, let me just open because we are already there. So in comparing means, you can tell we have the one sample t-test, we have the independent sample t-test, we have the paired t-test, and we have one-way ANOVA. So when I say go and read on t-test, I don't mean these ones. I want you to understand the t-test under regression, and it's in my notes here. T-test for significance of one coefficient. That is what I want you to understand. On t-test on comparing means, I will mention in class. So this one I'll discuss independent, paired, and so forth. I hope I'm not confusing anyone, but we're in the same page. Lastly, you should be comfortable with interpretation of coefficients. So how do we interpret those beta coefficients? Like I said, just remind yourself and you should be good to go. Let me stop there. And if there's any question, I think I'll respond to all of them tomorrow. Otherwise, thank you all for your time and have a good night.